And our final talk's titled CICD. It's a failed run unless your code is in production. And this is with Charity Majors. And Charity is CTO of Honeycomb, ex-Facebook, ex-Pars, ex-Linden Lab, operations engineer who accidentally ends up in charge of databases. And just before we hit into Charity's final talk, I just want to say thanks very much for having me, letting me come in today and MC all of the amazing speakers and talks. Hope you had great fun. I've certainly learnt a lot, and please feel free to look me up on LinkedIn or find me on the CTO Craft Slack channel. And hope you enjoy our final talk today with Charity Majors. Over to you, Charity.
Well, as we were just kind of commiserating in the green room, I wish I was there with you all. It's a little bit weird to be sitting here in my closet talking out into space instead of, talking out into a crowd. San Francisco Realty is what it is, though. It's time to fulfill the promise of continuous delivery. Some might say that it's a little bit past time. That's what I want to talk about. For those of you who don't know me, I am advancing my slides. My name is Charity. I am the co-founder of Honeycomb. I wrote the database reliability engineering book, and the observability engineering book is now in pre-release. So if you want to go download chapters from it, Liz Fong-Jones and I are busy, writing that right now. So if I were to ask each of you, do you do CICD? Because everyone does, right? We go to conferences, we talk about it all the time, we write pieces about it. But when it, you really dig into it, do you do CICD? You find out is that most people do CI. They have something set up to run their tests after they commit, which is great. But is that CICD? No. And in fact, the most important part of CI/CD, CI is just the spin up, man. It's just the clearing of the path to get to the thing that will actually change your life. Continuous deployment is what will change your life. It will change your team. It will change your personal career, all for the better. And honestly, if you aren't going to hook up CI to production, why even bother? Just run your test, just run it in a bash loop while true, and from your laptop, you'll get the same result for way less hassle, I promise. In fact, I will go so far as to say that, any CI/CD job that ends without having deployed your code to production is a failed run. It doesn't count. Simply being ready to deploy at any time doesn't mean anything more than the fact that your tests ran great. Reality is way more complicated than any CI/CD environment. It's way more complicated than your laptop. And you have to bow to reality. So let's talk about what a good feedback loop looks like when it comes to deployment, right? What it looks like is this. An engineer merges their change up to master or main, right? With any user available, any user-facing feature should be hidden safely behind feature flags. That should trigger a CI run to run the tests, develop, build an artifact, which is then, deployed or at least canaried to production. Or alternately, if you're way over on the paranoid side, deploy it to staging, and then, after it's been banged down for an hour or two, then automatically promote it to production. In 15 minutes or less is the important part here. And some things you'll notice about this feedback loop is that only one change set by one engineer at a time goes out, right? This is in line with the philosophy of you ship small changes constantly. There are no manual gates. There is no room for manual QA or, the variable times that you introduce by having to wait for your manager to get back to their desk to click a button. It is as important that it be predictable length of time as it is that it be a short length of time, in fact. And feature flags, what they do is they serve the hero's function of decoupling deploys from releases so that you can deploy constantly without having to coordinate, releases between teams or between, product, etc. This is the way. This is the way to build and ship software. It will change your life if you adopt it. If you don't have it, what did that do? If you don't have it, it gets bad real fast. And the important thing about this is that one interval between when you wrote the code and when it's in production. That precious interval, it is everything. It is the difference between disaster and success. If there's one place you want to start, the 4 DORA metrics that that tell you how high performing your team is. If there's one lever that you want to press to improve your performance at all of those metrics and become a more high performing team, it is right there. It is decreasing the amount of time spent before your code gets into production. Why? Because, it's software that has been written but not pushed to prod ages like fine milk. It's one of my favorite quotes to come out of Twitter this year. At that moment when you have finished, writing the code and solving a problem, you have everything. You have your original intent in your head. You know why you were trying to do it. You know what you were trying to do. All of the hoops you had to jump through to get there. All of the implementation details that you had to fight to figure out. Everything down to these specific variable names, and it's all fresh. How long does that last? A few minutes, maybe, if you're lucky, right? Definitely, it doesn't last past the point where you go and pick up another problem and you page all of that out and you page the next set of problems in. Which means at that moment in time when you still have everything fresh in your head is your best shot at finding bugs. The way to write software is by instrumenting your code as you go with an eye towards future you who has to understand it, right? And then having a short feedback loop so that you commit your code, it goes to main. There's nothing manual that needs to happen, right? It should feel like an atomic operation. You merge your code, and within minutes, it is live. And then you go look at it through the lens. Through the lens of the instrumentation that you just wrote, you ask, is it doing what I wanted it to do? And does anything else look weird? If you have good observability, if you practice good instrumentation, you will find upwards of 80% of all bugs right there. And the longer a bug has existed, it gets exponentially harder, more expensive, and more damaging for you to find it. If you can't find it in your IDE, your next best shot is right after it's been deployed to prod. And having it be a predictable amount of time, not long enough for you to go start working on the next thing at a predictable amount of time, lets you actually hook into the body's biological reward systems, like your muscle memory. It becomes muscle memory. You merge your code, you look at it. You don't feel like it's done until you've gone and checked. This also, having it be well under an hour, a few minutes, lets you hold the line against the most not seductive, but the worst, the biggest, the biggest hump that will send you down the wrong path is when it takes so long that you can't ship one change from one engineer at a time, right? Once you start having to batch up change sets, right? So that you're shipping 5 people's diffs or everything that's been committed since last night or whatever, you have decoupled that really crucial link that gives you ownership over your code, right? If your diff is going out, you go look at it. Ownership. If your diff is going out at some point, you're not quite sure when, and it will be going out with 5 other people's diffs, that's not ownership. You feel no instinctive, oof, I better go check on that. That link, that tight feedback loop between writing the code looking at it, understanding it, and then moving on is the fundamental building block of a high-performing team. I have never seen a high-performing team that doesn't have it. And have I ever seen a team that has it that isn't high-performing? I don't think that I have, but I'm not 100% sure. But it's almost a 1-to-1 ratio. If you don't have it, it starts to get grim pretty quickly. You kick off this, like, if your interval's on the order of hours, well, you start to batch together deploys, which means diffs start taking longer, and the death spiral begins, man. It's like, it takes longer, and therefore, your diffs are bigger, and therefore reviews take longer, and therefore you're paging a lot of state in and out of your brain, so it takes longer to do all of those reviews and to do all of those diffs, and now you're batching up your changes, which sever your ownership, which makes it really hard to figure out whose code is responsible for it, which means that you probably need specialists who are now deploying and debugging these things, because when you're shipping something that has 10 people's changes in it, and something breaks, well, then all 10 of them are going to get roped in to try and figure it out, or you're going to be bisecting to figure out who to assign it to. None of this is good. All of it takes time. All of these higher more coordination costs. And so you need more engineers, more teams, more managers, more product people, which all cost more time. And now you're like, and this is how you get to these teams that have got like fucking 150 people, and you're like, how does it take that many of you to build that? It's not because they're bad engineers, it's because they have terrible process. You can spend your life chasing down all of these pathologies and these side effects, or you can fix it at the fucking source. Sorry. You can fix it at that interval. You can make it minutes, 15 minutes or bust. That's a tipping point, I think. And it isn't just about the economic arguments, although they are massive. Do I have a slide in here about that? I don't know if I do, but I've been researching this for a while, and I think that you can basically, there's a rule of thumb. If it takes you X number of engineers to build, ship, and maintain this product, given the 15-minute or less deploy interval, well, if it's on the order of hours instead of 15 minutes, double the number of engineers it will take to build and support that project. Easily. If it's on the order of days instead of hours, double it again. If it's on the order of weeks, double it again. And if you think I'm being hyperbolic, I'm not. That might be like undervaluing it, because Facebook has done a bunch of, internal studies and everything that show that it's actually an exponential growth in cost. The longer the code exists, the harder and more expensive and more time consuming and taxing it is to find it and fix it. What would you do with twice as many engineering cycles? Well, if your deploy interval is in an order of hours, fix it and find out. But it isn't just about the economics. Like, the question of how well your team performs is intimately, high-performing teams get to spend the majority of their time at work solving interesting problems. And I'm not arguing here for, like, clearing the path so that you can spend 12 hours doing this. Honestly, no engineer has more than 3 or 4 hours a day in them of real focused hard work, moving the business forward, solving novel problems. 3 or 4 hours a day. If you can manage to get that every day, you will be on one of the most high performing teams that I have ever seen, right? That's not what's taxing. That's not the hard part. The thing is that lower performing teams, or teams that don't have this short interval, spend their time on so much of this other crap. Waiting on each other, like redoing work, like trying to figure out which work to actually do, fixing the problems from the work, being on call, firefighting, being too tired to think. This is what's draining. This is what makes software like not a great profession. Software should be a creative, fulfilling, wonderful profession that also doesn't eat up, 15 hours a day. It should be compatible with adulthood and life and parenthood. This is 100% a quality of life issue and an ethical issue. And we should be building these high-performing teams that are low in toil and high in what makes worth part of a very, a life worth living, which is autonomy and mastery and impact. Start by keeping your intervals low and your feedback loops tight. Oh, here's my slide. How much is your fear of continuous deployment costing you? There's your equation. If this is an interesting and powerful thing to sit down with and present to your higher ups. I do feel like the failure to roll out continuous deployment more rapidly is a signal failure of engineering leadership of the past 5 years or so. Before that, I'll give you a break, man. When Jez wrote the book on continuous delivery, this is the reason why it's continuous delivery, not continuous deployment. Most of the tools that you need to do this safely and well didn't exist. We've seen such a sea change in the past 5 years, just in terms of the tooling shifting from a very pre-production hardening mindset, where everyone gets their own dev environment and these elaborate staging environments and like all the tests, right? In the last 5 years, we've seen this massive gravitational shift over towards investing in production, investing in your tool sets, in progressive delivery, in real observability, which is not Prometheus and not Datadog, and it's not any other aggregates. Sorry, you can't do this with those tools. That won't get you there. But event-driven observability, where you can literally deploy, to a small subset of your hosts and go, what is different about the requests that are going to these nodes with the new version versus the old nodes with the old version, and request by user basis. You do need modern tools, chaos engineering, feature flags, observability, etc. But they're available now. So what's stopping you? The biggest objection I hear is this: it's a lot of work. We don't have time. And I get that it can be for engineering directors and VPs, especially, trying to sell this to your higher ups if they haven't read Accelerate. It can sound not enticing, right? Because it can sound like you're going, okay, guys, I would like you to accept for an indefinite period of time less developer work going to features and more going to stuff that's in the short term going to make us less reliable for some amount of time, not sure how long, but in the end, we're going to be able to ship within seconds or minutes, and like everything's going to go live right away. And people are going to go, that sounds terrible. I don't want that deal. First of all, try to get everyone in your org to read Accelerate. The data's there, but the thing is that we humans, when we get afraid or when we need more security assurance, we slow down, right? We grab for ballots, we stop. That's the physics of human beings. So our intuition doesn't serve us well here, because the physics of software is the exact opposite. The physics of software says that speed is safety. The physics of software says shipping small diffs continuously is the safest way that you can possibly operate. And when you slow down, when you stop that heartbeat, that's when you get into trouble. So, make your arguments by converting them into dollars, by converting them into retention, attraction of high value employees. Make your arguments passionately. They're true. You have that on your side. But make them. Like let's do let's move this CICD train. Let's get it jump started and moving again, because it's the only way to work. The end. Thanks.